Hi everyone, it's Mr. Hamilton here, and this is a video where I'm just going to go over the three right-hand rules that we learn in grade 11 physics. And I'm actually going to have my kids help me describe some of these. So the first right-hand rule is the magnetic field around a wire. So Felicity's going to come and help us do this. So your thumb points in the direction of the current, and your fingers wrap in the direction of the magnetic field. And what you can see from her fingers there is you can see that they are coming down the front and going up the back. Her hand is going up the back and down the front. So that's what we can draw on this particular diagram. So here's our magnetic field. It's going to go in that direction that the fingers were wrapped in. So any current carrying wire, we put our thumb in the direction of the conventional current and our fingers are going to wrap in the direction of the magnetic field. And the same thing for the bottom. In this case, we're going to point our thumb away towards us, away from the page. And as we do that, we're going to see, as we point it away from the page, we're going to find that it's wrapping in a counterclockwise direction, just like so. So the magnetic field is going in that direction. So that's the first right-hand rule. The second right-hand rule is to find the north pole of an electromagnet, of a solenoid. And so TJ is going to come and help us with that. The first thing worth noting is that the current always goes, conventional current, from positive to negative. So it's going to go up the front and down the back. So here comes TJ to help us with this in identifying the north pole. So TJ's got his hand here. He's going up the front and down the back. And where's your thumb pointing, TJ? What way is your thumb pointing?
To north.
To north. So that way over on the right is going to be the north pole. So that means this is the north magnetic pole. This is the south magnetic pole. And it's worth noting that I could have not told you what direction the battery was facing and what direction the current was traveling in. But if I told you that the north pole was on the right, you could have used that and you could have said, well, the north pole's on the right, and it's all backwards here, it's mirrored, so it's been a bit tricky to film. But on the right, I'm going to point that up the front, down the back, means that that would be the direction of the current because my thumb is in the direction of the north magnetic pole. The third right-hand rule is the motor principle, in which we find the force on a wire. And we do that by, again, using our right hand, but it's an open hand in this case. Our fingers are going to point in the direction of the external magnetic field. So they're pointing from the north to the south. So I'm trying to line it up on the screen here with what's on the actual screen page in front of us. Now you'll see that the thumb is pointing into the page. And so what does that mean? Well, it means the force on that wire is going to go downwards because my palm is open in the direction of the force, like we're going to push it. So that's the first diagram. Let's add that to the diagram up above. On the diagram at the bottom, we're going into the page here with the current because it's positive on this side, and we're coming out of the page on that side with the current. We've already established that, or based on our right-hand rule, going into the page, if the current's going into the page and the external magnetic field is going from the left side to the right side, that what's going to happen is that's going to force that side of the wire downwards. And then the other side, if it's coming out of the page, I'm going to try to flip my hand around and show that. Again, my magnetic field is going in that direction from north to south, but the current's coming out of the page, so my thumb's pointing out of the page, and that side of the circuit or of the loop is going to be forced upwards. And so this particular motor is going to spin in a counterclockwise direction. Counterclockwise direction. So those are the right-hand rules. You may want to pause the video here and just write down what the rules are and write the diagrams. Maybe seeing them all on one piece of paper would be helpful for you. But there you go. There's a wrap on the three right-hand rules of physics, grade 11 physics.